This was your assignment. Any questions? 1, 2, 3, 4, 5, 6. I'll have to take attendance soon. No questions? All right. Asymptotes. I think part of this unit should have everybody pronounce it properly because it seems there's always at least one or two people who are like, I'm trying to think, Jared Unruh, how did he say it? Like asymptote or something? I can't remember. It definitely wasn't right. Okay, got distracted. I gotta take attendance. I'll give you another line to take down. I'll talk about it. So I'm done taking attendance. Username, Morris L. Password. It's a secret. My password is let's learn together. What? It didn't work. Password. Try this again. Let's learn together. Good gracious, heavens to Murgatroyd, what is going on? Let's try again. Oh, finally. Pre-calculus. Anybody do any cooking around their house? Like cutting onions or garlic? Sticks with you for too long. I'm like, what's that stink? My hands. So like onions. Good thing it wasn't garlic. Garlic lasts longer.
Well,
Garlic tastes good. Well,
you know how I'm doing that like program for volleyball?
mm-hmm.
So part of that is a nutritionist is gonna teach us how to cook a meal.
Oh, that's kind of cool.
So I think we're gonna learn how to make like, I think the coach said like lasagna or something.
Oh wow.
It'll be like leftovers or something.
Oh, okay.
And like granola bars. So.
Oh, like homemade granola bars. That's cool. I'd like to learn stuff like that. I'm not a great cook, but I do the cooking. And yeah, I just want shortcuts to make it easier. All right. An asymptote is a line that a curve approaches but never reaches. You'll see it visually in a few moments. A vertical asymptote is a vertical line that corresponds to a zero in the denominator. If a value for x causes a fraction to have a zero denominator, that value is where the vertical asymptote would be. What does that look like? Well, let us look. Here's something I like to call Desmos. Let's learn together. It's like October 7th. I'm a little bit tired of hearing myself say that. Okay, so let's just keep it simple. First example, 1 over x. Let's put this bad boy in projector mode. So 1 over x, the fraction is 1 over x. When x is 0, you would have like an impossible fraction. Not allowed, can't have 0, non-permissible. So where x equals 0, these lines approach, but they do not meet it. And so like you could put in the asymptote. So like x equals 0. So it doesn't matter how far along you go. You can follow this for a long time and go, oh, okay, yeah, they're touching. Are they really? Hang on, let's go to 46 because I hear that's a good number. See? Look. They never will touch. Oh, it looks like there's a lot of space between them. You go on forever and ever, they won't touch. And so that also would include, you can get creative with the with your denominator. I'll just keep it 1 on top just for simple sake. Let's say x minus 1, x plus 1. So here, your asymptotes are x equals 1 and x equals negative 1. And so if you put those in, x equals 1, x equals negative 1. Again, like it looks like they're touching, but they aren't. And so that's how it works. And you can keep going with these asymptotes, like x, x plus 2, and so on and so forth. You won't get any questions like this. You won't, like 7 degree in the denominator, but it's good to kind of have that understanding. Are we okay? Any questions? All right. Jamie, did you get this written down? Yeah, okay, good. All right. So let's move on. Ba, 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 ba. Ba, 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 ba. Horizontal asymptote. These ones are a little bit weirder. Oh no, I'm going to tell you the story after I'm done recording. Oh, it's bad, but I'm just going to do it that way because that's how I'm going to do it.
Okay.
Thanks, Gavin. Gavin's got my back. Did I tell you guys how I had to kick out these drug dealers when I was at Dakota? I was acting principal because the 3 were away. And I had to kick out these dudes, and they're these sketchy-looking guys in this cafeteria, and I'm walking there by myself, and I'm not a confrontational guy. I've been in exactly 0 fights probably in my entire life. I don't know where this is going to go. But there's this table of hockey players. I remember the one guy, Mike Viola, super nice kid. I don't remember who else was with him, but they're hockey players. I said, hey, guys, just a quick question. I got to go over there, and I got to deal with this. If something happens, you guys got my back? And they're all like, I'm like, no. Like, sit down. Just want to know. But that felt good. Like, I get in some kind of trouble. And it was it was like go time. So that felt good. Mike Fiola, what's he doing with his life? I haven't talked to him forever.
Probably something of business. He's a hockey player, he probably went into business.
I should see if I can look him up. Yeah, hey, that's the thing. That's your guess. There were these guys, like, I got along, any student that I knew, got along with. And there were these guys who were getting ready to fight. I was in the office and they could see on the camera. They're like, go, go, go. I'll go running down the hall, passing other teachers and like, come here. And these 2 big guys, and one of them, his name is Mahmood. I think I might have told you, got jumped in the cafeteria one time by 3 guys. Did I tell you guys about that? Handled himself. He was jumped. Guys from a different school came. He mopped up the place. Anyway, so Mahmood, I get in between them, and I have like a hand on Mahmood's chest, and I can't budge him. I'm not a weak person, but I can't budge him. He's about my height, and eventually I put both hands on his chest, I go like this, and I can't move him. It was just weird. And the other guy was way bigger. I'm like, Jason, get out of here. And they're just yapping at each other, what are you going to do? What are you going to do? All this other stuff. Mahmood is the guy who I had to suspend that one time. Did I tell you this story? He came with a weapon to school. Someone found out and sent him to the office. And he's very soft spoken. He's always very nice and respectful to me. Oh, Mr. Morris, if I can, I'm gonna get in so much trouble. Sorry, man. I get that you can't bring a weapon to school. There's no wiggle room. You just can't. And so at the time, I had more hair. And as I'm walking him out, kind of walking to the door, just chatting, and he goes, Mr. Morris, one more question. Sure, what's that? He goes, what do you put in your hair? And I remember what it's called because I had to buy it at the store. I said, it's called short and sexy. Okay, see you, Mahmood. It's like, those are my final words before he leaves. All right, a horizontal asymptote may be crossed, and therefore the resulting graph is said to exhibit asymptotic behavior. To find a horizontal asymptote, there's 2 ways, 2 that we're going to run into. Number 1, if the numerator is of a lesser degree than the denominator, the asymptote is y equals 0. So if it's like x over x squared, the asymptote is right along the x-axis. If the numerator and the denominator are of equal degree, we divide the leading coefficients, and that is your asymptote. Desmos, let's have a look. So, simplify this. Just keep it. Let's just see what happens when it's x over x.
Was Mahmoud a football player?
Mahmoud was a scrapper. Yeah, I don't think he played any sports. Okay, so let's say x minus 1 over x plus 2. Just making stuff up. So here at where x equals negative 2, that's this line right here. That's going to be our vertical asymptote, like we were just learning. Now, when they have the same degree, you divide their leading coefficients. Leading coefficient on top is 1. Leading coefficient on the bottom is 1. 1 divided by 1 is 1. There's your horizontal asymptote. So I'll put in the asymptote so you know x equals negative 2 and y equals 1. Does that make sense? Now this is the same degree on top as on the bottom. So you divide the numerical coefficients. 3x squared blah 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 over 2x squared blah blah blah, 3 over 2. If the bottom has a mute these for a moment. If the bottom is of higher degree, then remember it's just going to be the x-axis. So x minus 2, we'll say. So now this is where it gets a little weird because, like I said, the horizontal can be crossed. This part crosses it. Otherwise, these two parts approach but never meet it. So horizontal asymptote here is y equals 0. The vertical asymptotes, x equals negative 2 and x equals positive 2. If I were to add another like binomial here, then it would go back to it would go back to 1. Is this making sense?
Will we have to draw that?
Yeah. It's not as hard as you think. But yeah, you will. We'll do an example, or 2 or 3. Just to highlight, let's make it simple again. When we're talking about the binomial, so if I put a 4 in front of this, that means the horizontal asymptote will be at 4. Put a 2 under this, the horizontal asymptote will be at 2. 3, it's 4/3, so it's like 1.3-ish. Well, here, y equals, just 4/3. So why Desmos is good to play with. Just takes a couple seconds. You can put stuff in, but do not put the work in there and then just copy it. You need to be able to do it on your own by hand. Questions about that? So here's the rest of the notes and the assignment, and then we'll do some questions, some examples. I'll try it on graph paper, and if it's terrible, then tough. Then you guys can let me know. I need a compartmentalized pencil case. Okay, page 115 is the assignment. Everybody's got that, right? Why does it do that? Don't like it when it does that. Okay, I already forgot. What did I say? 115? Oh, see the examples? Why don't I just do I'll just make up some examples. I'm sorry, I thought there were better examples here, but there aren't. So let's figure this out. So we'll start relatively simpler. Like I said, I'm going to try this with just regular markers. If it's not very visible, then let me know. Just need to focus this silly goose. All right. So let's start with something simple, like y equals x over x squared minus 1. Is that okay, or would you rather use that bigger marker? It's okay? Okay, let me know if it's not. So in this case, what we need to do is we need to find the non-permissible values. So we're going to have to factor this to find out what, and it's going to tell us what the vertical asymptotes are. So y equals x over, this is a difference of squares, x minus 1, x plus 1. So I'm making this way too big, but whatever. Too late. So at x minus 1, at x plus 1, those are our vertical asymptotes. What is our horizontal asymptote? Y equals 0. Why? Exactly. Now the way that you draw these asymptotes are broken lines. And you'll get the hang of like how these, like the relationship between how these things go and so on and so forth. But you can also like use a, what's it called? A table of values, just to kind of find some points to figure out where they go. So we know we can't use 1 or negative 1. So let's just start with 0. When x is 0, y is 0. Oh, you know what? I'm going to draw the horizontal one as well. Horizontal one can be a little bit tricky because it's right on top of the axis, but try and show it like if you draw just a hair off of it, so you can see the broken line. Do you know what I mean? So if I did that right on top of the line, you wouldn't be able to see it very well. And I, case in point, right here. But so, anyways, x equals 0, y equals 0. So if I say x equals negative 2, okay, so x equals negative 2. So it's negative 2 on top, negative 3 and negative 1. So it's going to be negative 2 on top, negative 3 times negative 1. So it's going to be 2/3, negative 2/3. So when x is 2 is negative 2/3, so it's about there. Now that is the only point I need to put on the left side of the asymptote because it's going to have this shape. It's not going to cross the horizontal asymptote. It's not going to cross the vertical asymptote. So with a smooth curve, and it should look like it's approaching the asymptotes, like it's getting closer. You draw. This is clearly not amazing. It should always, you'll see it on Desmos right away, but it should be moving to the right as it goes down, should be moving up as it goes to the left, but approaching, not going through, no kind of hard turns or anything like that. We'll try positive 2. Stop me if I'm going too fast or something's not making sense. Positive 2 is going to be 2 over 1 times 3. So it's going to be 2/3. Positive 2, 2/3. Draw our curve. So we know in the middle, x is 0, y is 0. I forgot, I kind of left that point. Now, what's going to happen here? Well, you know what? It's not a guarantee. Because we have this kind of shape, chances are what's going to be in the middle is one of those ones that kind of comes down one side and goes down the other. So we got to pick a couple points in between these two. I should have picked, to make it an easier example, I should have used 2 or something. But anyways, we're going to have to use like 0.5 or a half. So if I say negative a half, and I'll just do my work here. Negative a half, so it's negative, I'll say negative 0.5 on top. Negative 1.5 on the left, and 0.5 on the right. So it's going to be positive. And it's 3 over 2 times 1 over 2. It's going to be 3 over 4 on the bottom. It's 1 over 2 divided by 3 over 4, which is going to be 4 over 6, which is 2/3. Positive 2/3. So it's going to be like in here. 2/3 and a half. Yeah, about there. Remember, we had our 0 as well. So almost guarantee the next point is going to be right here. Then you'll see the relationship. So negative a half, and it came up with, what was it? 4, so 2/3. So if we do a positive a half, that's a half over negative a half times 3 over 2. So that's 1 over 2 over negative. So it's going to be negative 3 over 4. You flip and multiply. That's 4 over 6, 2/3. Yeah, I was right. So it's like there. So what that means is I'm not a good drawer. Well, see, I went right through the line. Anyway, don't do that. Use pencil. I'll punch this into Desmo so you can see. This is terrible. That's why you need a pencil. You don't have to plot a ton of points. It's finding the zeros. That's really important. I'll punch this into Desmos quick so you can have a looky look. So this is, what do I got? X over x squared minus 1. Is that what it was? X over x, yep. And that's what we got with our asymptotes drawn in. Any questions? Now you should. Oh, hello, welcome here. Too late, just go to the office and sit there. You should, let me go back to the visual here. Either identify these points like on the graph, or have a table of values just so we can see where it came from. So you're kind of showing your work, you're identifying what's what. If you have a table of values and you don't identify the points, that's fine. It's clear where you're getting it from. But if you're doing stuff in your head, which is what I kind of would normally do if I'm getting stuff ready for class or whatever, doing stuff in your head, then I don't know if you understand it, where you're getting it from, what the axes values are, things like that. Make sure you kind of show your work. Are we okay with this? It might be a little bit overwhelming. Take your time. I'll do another example. Maybe I'll do one like from the assignment. Okay, so like for the beginning, it says, for each of the following, find the vertical asymptote and state the domain without graphing. By the way, the domain of this is x cannot equal positive or negative 1. X is an element of the reals. Those are the only values that x cannot equal. Right? Because that puts a 0 in the denominator. Okay, back to the question. So here it says find the vertical asymptote. So basically you're finding the zeros. Now you might not, yeah, you probably always will have one. But like this, you'll have to factor. This you'll have to factor. I don't want to just give all the secrets away. For each of the following, find all horizontal asymptotes without graphing. So here, this is much easier. You don't have to do any factoring or anything. You're just looking at the top and bottom. Is it the same degree? Then you know what it is by taking the leading coefficient, you divide those. If it's not the same degree, then it's at 0. For each of the following, the domain, the vertical asymptote, horizontal asymptote, match the following graphs. Oh, you're not even asked a graph in this assignment, I forgot. Okay, so I've probably said enough. Are we good to go? Is that enough for you? You will need to graph though, so I just got a little bit ahead of myself. Like, in the next lesson. All right, I'm gonna stop recording.